Thanks. Okay, so welcome everyone. Today I'm going to be introducing you to the Earth System Documentation Project, or as it's more commonly known, ESDoc, in particular with regards to its role supporting CMIP6, so Climate Model into Comparison Project 6th phase. So this will serve as a high-level overview to ESDoc, and I'll then hand over to my colleagues Atef and Mark, who will go on to talk in more detail about the Errata service and the tooling behind ESDoc, respectively. So without further ado, so what is ESDoc? Well, it's an international project, and it has the central aim of supplying high-quality tools and services in support of Earth system documentation creation, analysis and dissemination. So in relation to CMIP6, in short, it acts as a documentation ecosystem for the full end-to-end workflow. Now I've included this diagram as big as possible on this slide because this diagram summarizes very effectively the role of ESDoc in the CMIP6 documentation workflow. And as you can see, I'm not sure if can you see my cursor?
No.
No. Okay, fair enough. I'll not point to things with the cursor, but try and follow this with your eyes.
I can see it.
Point things out.
Okay, now I
someone,
can see.
Someone said they can.
Yes, it is visible.
Oh, I see.
Sorry.
Maybe if maybe if I'm excellent. All right, I'll try and point to things, but hopefully it'll make sense if I'm not. No, that's absolutely fine. Sorry. So yeah, so in terms of this diagram, as you can see, there are many different components, and these represent the components of the workflow. And ESDoc is tasked with supporting the documentation for all of these different components. Now, some of them need input by the various modelling institutes involved in CMIP6 simulations, and these aspects are shown in blue. Whereas other aspects, it's possible to fully automate, and ESDoc does that. So that those are shown in red. So just for example, looking at the top row here, the details of the project, in this case CMIP6, and all the various experiments involved, that's the details of those are fully automated by ESDoc, whereas the party and citation, I'm going to define these terms in a second, but these two things need input from, well, the parties themselves, these modelling institutes. But ESDoc, where input is required, ESDoc streamlines that so that it's as simple as possible for the people involved, basically. And let me just see. I'll summarize the terms now, I guess. So a simulation here is a run of a configured model which has conformance to numerical requirements of an experiment. Experiments there. That also has some sort of performance when it's run on a given machine, and it obviously produces some output, and that's archived onto ESGF. There's also an ensemble, a term we use as a set of simulations who have access members which describe how those simulations differ. A party is just what we use to describe a modelling institute or some person from it, or anyone really organized, involved, in the modeling process. And they have a published reference, and that's kind of encapsulated in a citation. So they're the main terms. Finally, we've got Errata. So if there's any problems discovered with something that's been published, some documentation that's out there, that consists of Errata, and Atef is going to tell you all about that in the next talk. So yeah, overall, in this way, by managing all of these components and supporting documentation for CMIP6 in that workflow, ESDoc is enabling the scientific community to better understand and utilize Earth system model data. Just to continue a bit more on the theme of motivation quickly, I've mentioned, there's all these components in the diagram, but for each one is complicated enough in itself. So for example, for CMIP6, we've got 23 model into comparison projects, almost 300 experiments, around about 60 modeling institutions internationally, thousands of variables. So it's, if you can imagine the combinatorics of this, it is indeed very complicated. And I guess the ultimate goal for ESDoc is just simplify documentation creation and access. So yeah, that's a bit about kind of the motivation. So let me just summarize where we're at for CMIP 6 and the main resources that ESDoc provides in relation to CMIP 6. So the two core assets are a website, the ESDoc website, and a further info URL. I'll not talk about these in detail right now because I'm going to go on to cover these in future slides. But they're the main access points, if you will, and that allow you to find the controlled information in a systematic way. And all published documentation is readily available to view. And you can do various things such as explore and compare, which I'll go on to talk about. Just to clarify some wording I've realized might not be too clear in the slide. When I say all published, I just mean all the documentation that is published, not all documentation, because within, modeling institutes need to provide input, which basically means that they provide it when they're ready, and ESDoc automates it so that until they're ready, some of that isn't available yet. But ESDoc's been operational since December, so late 2018. Plenty of published documentation available, and like I say, new additions are coming in when the modeling institutes provide more information. So onto the website, which, like I say, is one of the two key resources we have for CMIP 6. And I'm going to cover some of the key applications we provide via the website. But this is just talking about the kind of splash. This is what it looks like. Unfortunately, because I'm just giving a kind of brief introduction, I can't actually take a quick tour through these URLs, but I've hyperlinked them so that I encourage people who are interested to just click on the links quickly. But we have the root page is es-doc.org, and we also have a kind of splash page for CMIP 6 specifically, which is just /CMIP 6, and it looks roughly like that. And as I'm going to kind of cover in the next slides, this is a kind of your portal to exploring CMIP 6 documentation. So just to cover some of these specific endpoints that we have. So to begin with, you can search through the published CMIP 6 documentation by our search web application at search.esdoc.org. So you can use it to discover and view, for example, CMIP 6 experiments, documentation on those, documentation on the model intercomparison projects, on any published models, for example. So I've put a screenshot here just to give a brief idea. In the interest of time, I'll say that much, but please do explore that URL. We also have an Explorer web application, which can be used, among other things, to explore all published model formulations or to pick out metadata by institute, or I think by model or CMIP 6 realm. Now, this is also the app which displays the further info URL, which I'll be covering shortly. And just generally, it renders the various documentation in a nice user-friendly way. So as you can see, things are kind of have titles that make it clear the different sections. So we try to make it as accessible as possible. Finally, in terms of the core web applications I'm going to cover, we also have a comparator, compare.esdoc.org. So in this case, it's enabled for CMIP 6, unlike the other two, which are all up CMIP 6 and ready. So it's come very soon, but currently we have the fully functional CMIP 5 comparator. So this is what that looks like. You see CMIP 5's in the corner there. But when it's ready for CMIP 6, it should look, I think it'll not look too different. But obviously it'll be for the CMIP 6 era. And with the compare, as the name says, compare and contrast, for example, model component properties. I think that's shown in that screenshot actually. So comparing and contrasting, the comparator is the application. So as well as web applications, we provide a number of web services. So first of all, there's the Errata service for the discovering registered issues and amendments to the published data sets. Atef's going to talk about that, so I'll not dwell on that one. Secondly, we have a citation service. So as with the Errata, actually, this is not just managed by ESDoc, but also we collaborate with a few other groups on these. So these URLs, well, not for the Errata, but for the citation service, take you externally to the ESDoc site, but we do collaborate to manage those. Further web services, we have some utility libraries provided. So PyESSV, I'm trying to say that's a bit of a tongue twister. So the Python Earth Science Standard Vocabularies, that's an acronym for, and that's a utility library provided at the endpoint given there. We also have the utility library, which provides kind of the API for the documentation creation and publication that goes on behind the scenes for the site and the further info URL. We call it PyESDoc, and that's provided there. Okay, so onto the further info URL, which, as I said, is the second of these main resources for CMIP6 that ESDoc provides. So essentially, it's two different things. It's a property that is provided in data sets and a corresponding web page. So I'll start by describing this property. So any CMIP6 netCDF dataset will have this further info URL with underscores between property, and actually it'll have that as a netCDF global attribute, and you can just access that on your datasets. So assuming you have something that's a genuine CMIP6 dataset with a choice, so whether you might choose to go on the command line or via Python inspect that property to get, and it'll give you a URL, which I'll discuss in a second. But just to quickly show you some of the ways you might be able to grab that property. So if you are familiar with the popular command line tool, ncdump, you could do that. You could do an ncdump on the file, that CDF file, and then go and find it, or you could kind of pipe it to grep to get that information out straight away. Also, if you go via Python, for example, the CF Python tool or the CFDM tool, which is another one you could use, a way you could do it, three lines here, just import the module, read in the file, grab one of the fields, and then just get the property. But whatever tool you use, basically just get get the netCDF global attribute. It will give you this URL, and the URL will then obviously open that in a browser. It'll take you to a page on the Explorer web application, and that'll give you various different information relating to that data set. So I've got a link here to a kind of a working example, but just to show you roughly what it looks like if your further info URL was this, and that's what was given in the data set. Follow that in the browser, and you've got links here to the various different aspects that might interest you. So the Errata, the citations, all the various ESDoc kind of component information, as I was discussing in previous slides. So that concludes my very brief introduction to the ESDoc project, or kind of Earth System Documentation Project. To just remind you of the full name with regards to CMIP6. Just as a final note, on these slides, I've hyperlinked various URLs. So please do follow those as if you're interested, because in this brief introduction, I haven't had time to just even click on them and kind of give you a very quick tour of the site. But obviously, that's the best way to learn about ESDoc. Just explore these different aspects. Any questions you have? I'm not sure if we're doing the questions after we've all spoken or straight away, but yeah, I welcome any questions.
There are
and actually, I haven't. I'm just thinking if there's any questions in the chat, I haven't seen them. Yeah, sorry, I didn't. I've been obviously presenting on full screen, so I haven't actually seen those immediately. Can I stop sharing and I'll have a look?
Absolutely. The questions are in the HackMD document. If you came in late, I can kind of post a link to the document there. So I've just placed the link in the chat for you.
Oh, sure. Yeah, I've seen it. Thank you. Just follow that through.
Right, and
so have we got time now
right at the
to go through some of these, or shall I think about them? Sorry, someone's trying to go ahead. If someone was trying to say something.
I think let Atef go on to his presentation, and then we can answer questions at the end.
Great, thanks.
Hi, everyone.
Perfect by me.
Yeah. So my name is Atef. I'm a research engineer at IPSL in Paris. Today I'll be talking to you about a project that I've contributed in when I first joined IPSL back in 2015. Nowadays the project is up and running. It's known as the ESDoc Errata, and it's a very nice project, and I think you should see what it's all about. I'll start the presentation then. Do you actually see my PDF?
Yes.
Yes. Nice. So yeah, like I said, this is the Errata service presentation, and it comes into a context of the ESGF CMIP6 and Cortex data, but it's not exclusive to those projects. The basic request for this type of project was based on CMIP5, actually, climate intercomparison data. But then when we implemented the service and it was up and running, it coincided exactly with the launching of the CMIP6. So we seized the opportunity to make people use the Errata service with CNRS data, but it's not exclusive to it. So the main motivation that made us think about launching such a project was the fact that in the climate community, we produce terabytes of data in every iteration of CNRS. And every time those data are produced and published, it never fails that we discover that there are a few issues here and there. Maybe the axes are upside down. Maybe something's wrong with the metadata in the metadata files. And generally, the data providers or the data managers, what they do is they retract the data to prevent further people from using erroneous data, but they don't have a means of telling people why they retracted the data or what's wrong with it. And there were a few efforts, to be completely fair and honest, like there were a few local repositories in everyone's little server with a little database behind, and maybe a front end if they are being generous, that lists all the data that have retracted and why they have retracted them. And this has become such a problem for us, with the data being bigger and bigger and having to manage terabytes upon terabytes of data. So we started thinking about whether we are being fair or not, and we started to think that we are compromising some main components of the FAIR 4 principles, mainly the reusability of the data. So if someone has the same data as someone else, why is he having different results? And it turns out because they're using two different versions of the same data set. And as well as the accessibility, because someone who has duplicated, replicated, or downloaded a set of data and he no longer has access to it because it has been retracted, he has no recollection of why that data was retracted, and the data that he has basically invested heavily, maybe in downloading it, maybe weeks, maybe months, maybe, is basically useless. So the Errata service was basically a project that aimed into reaching the goals of having a centralized place, server basically, that is accessible by everyone, in which that every time there's a new data set that has been published, a new version of the data set that is published to the ESGF data store, it has to be motivated by an errata that has been already published. So the data manager is responsible of saying, I'm retracting this version, I'm publishing this other version, and here is the reason why. So this was the idea that we started with. And to do so, we have isolated the targets of having something like a bug tracker that is available in GitHub or Bitbucket or Jira, something like that. But the thing is that with the existing solutions, we realize that there are a few constraints, because the application that we have is a little bit specific. It's a scientific application that has a little bit of sensitivity in terms of the scientific context, but also in terms of how sensitive the data is. So if the errata that we are producing is accessible by anyone, and anyone can log in and say whatever they want about the data set that we are publishing, it can compromise the reports that are based on these CEMIP data, which is something that is big, and we cannot allow everyone to just fool around and do everything to do with it. So we did what anyone would do. We just said, you know what, let's do our own project. Let's start it all from scratch. We can maybe take a little bit of inspiration from the existing products, but we will create our own. And we will make it like an application that requires authentication and authorization. We will control whoever rights on this data store, metadata store more like, and we will have a little bit of constraints to make the data that is stored on the errata a little bit of high value. So it will require to have a unique title with an elaborate description, with a list of the affected data sets and some optional stuff like the materials, like maybe some pictures and figures, and maybe external URLs that further explain what the problem is that has been detected with the data. This graph generally explains the implementation that we have. You don't have to necessarily understand what's going on here, but I want to go through it nonetheless. So it starts by the stakeholders, which are basically the data managers, the data providers, who maybe they are notified by someone else in the community, maybe they realize the mistake themselves and they create an errata. And to do so, they have to go through one of the two clients that are available to them, either the command line interface, which is a Python package that can be installed and used, or go through the web forms. So one is maybe more programmatically easier to use, and the other is more user-friendly, because the web form, let's face it, it's much more straightforward. Once the errata information has been entered, it goes to the web service, which takes care of making sure that the person who is typing this is allowed to type it and is saying good stuff, validates it, and then stores it. But not only that, because we have successfully integrated the errata service with the PID service, with the persistent identifiers system that has been introduced by our colleagues in Germany, the DKRZ. What they have created is basically a database of metadata that every time a data set is published on ESGF, there is a handle that is created in parallel that is attached to that specific version and can host other metadata, including the errata. So, and that handle is there forever. It can never be retracted. It can never be deleted. Even if the data attached to it has been deleted, the handle service will always provide you with the metadata that has been attached to it. And that was very big for us in the errata. So we used this to have an integration. So I'll come back to that to see the application that we have used to this. And via the database that we have locally in the errata and the handle service, we provide a return for the users who can request and see if a specific data that they have in hands, that have been downloaded and maybe using for their paper, has maybe been declared in an errata or not. Sorry. So in order to contribute to the errata service, we try to make it as easy as possible, but it's still, there are a little bit hoops you need to go through normally to contribute to it. But we relied on GitHub for authentication and authorization in order to not reinvent the wheel, because we said to ourselves, maybe, okay, our application is a little bit specific, but if there's an ID provider that we can use, we do not want to have that responsibility on us. So we use GitHub, and I think in ESDoc, this has been generalized on other applications. So I think having a GitHub account is not very high threshold to have in order to contribute to the errata service. So once you have a GitHub account, you have to generate maybe a personal access token if you want to use the command line. The process is easy and it is documented. So if you have any questions whatsoever, you can either refer to the documentations or maybe shoot me an email. I'll be glad to walk with you. Once that has been done, you can go to your console and basically create two files, a JSON file that contains title, the description, the project that is required. So you can see that this example is a little bit outdated because it was back when we were still talking about CEMIP 5 data. The severity and some optional stuff if you want to have your errata a little bit more prettier for other people. But the most important part is having a list of the data sets. And this is a problem that even now we still have with the Errata, is because having the exhaustive list of all the data set that has been affected by an Errata can be a little bit tricky, especially if you have an entire experiment that has faulty data. So you have to list all the data set that have come from that experiment, which can be a little bit tricky. There are a few workarounds that are available, but the Errata service does not provide something that helps you generate the data set list. You need to have it ready and listed in a TXT file. So once you have the JSON and the TXT file, you can push them to the Errata server, and you will be rewarded with a nice success message, and your local files will be updated as well with a UID and with links that are to your Errata. So this is the old way of doing things. This is the first way that we started doing the Errata stuff. But then we evolved. We told ourselves we want to attract as many people because this is a community project. This is something that has value when the community uses it. So we have big interest in making it as user friendly as possible. So we started using an Errata web form in order to have more feedback from the community. So basically, all you have to do is go to the Errata landing page. You have to use the button to log in. Once you press that button, you will be redirected to log into your GitHub account. Once you log in, you will be redirected to the same page, but this time, instead of having a login, you will have the create button that will allow you to have access to the form. And once you fill in the form, you will be guided with the little error messages if it's not conform or whatsoever. And then once all the fields have been filled, you can press save, and your Errata should be saved. So this is what the landing page of the Errata service looks like. We can see it actually in the browser, but basically this is it. This is a list of the available Errata with a little bit of flags that you can use in order to find your own, if you're seeking something in particular. And once you click on a specific issue, you will have the fields, the metadata of the Errata. So you will have the title, the project, and some facets of the issue that has been harvested automatically from the dataset list. The dataset list you will find effectively in this little page that will list all of the datasets. Of course, we do not expect an end user who has data to go through all the Erratas and manually look to each dataset to see if the dataset he's using in the paper or that he's interested in is concerned by an Errata. This is where the PID integration came into play. So go on a second, if I can quickly stop sharing the presentation and share my browser instead. So if I'm in here in the landing page of the Errata, so if I want to say show me all the Errata that has been declared for the data that has been published at IPSL, I can select this Errata completely at random. I'm going to grab a dataset ID, and I'm going to put myself in the shoes of a researcher or someone who's interested in the data and who wants to see if this dataset in particular is concerned by an Errata. So what I do is I go to the search page, I drop my dataset ID, and I tell them check this Errata, check this dataset for me. Is it safe to use or not? And the Errata service has basically all the versions available for that dataset. And this is thanks to the integration with the PID service, because the PID enables the versioning chain of all the datasets and can tell you whether it has an issue or not. So what I see here is that this particular version of this dataset, it has been the first that has been published, and it has a known issue that I can see here. I can see if to see if it concerns me or not, if it's resolved or not, the severity, etc. And I can also see that there is a new version that has been published. So maybe if this issue is something of importance to myself, I can instead use the new version and get on with my work. Back to the presentation real quick. today we are at 4.5 million of data set that has been published in CMIP 6 with disregard with the replicas. If we consider the replicas, it's around 9 million. And today we have like around 170,000 data sets that have been affected by Errata. So we have around maybe 3.7%. And to tell you the truth, I think the real number is much higher than that, much bigger than that. And that's a little bit of work that we need to do in the side of the Errata to make the community, first of all, more aware of the existence of the tool. And second of all, more user-friendly, because I think there are a little bit of efforts that can be done by the community in order to create a few erratas, but if the errata service is not easy to use, they will skip it if they can. So these 170 datasets are scattered on 314 issues, but are scattered on different status. Some are new, some are resolved, some are declared as won't fix. So you need to use another version, and some are on hold, and with different severities, of course. Some are low, high, medium. The pretty much third splits in every severity. So this is just to talk a little bit about the PID service. So if the PID service is basically what it provides is JSON returns such as these. It contains metadata that is attached to data sets that have been published. It's not on the aggregation level of the data set. It goes deeper into the files specifically, and it has a lot of different useful metadata, including which I find important for the Errata service, for instance, is the Errata IDs, but also the replaced by, for instance, that points into the subsequent versions of the data that has been used. And this is what we use basically in our lookup function that I have shown you earlier. So that is the state of the Errata service as it is today. I think we have a lot of work that is ahead of us, and we have already a few not complaints, but requests from the community. First of all, to make the Errata service a little bit more open, because as things stands right now, you need to have a GitHub account and you need to talk to a moderator of the Errata in order to be authorized to publish Errata to the service. This has been seen as a little bit of problematic to some users who want to just say, hey, I have an issue. Maybe instead of doing the workflow like we do today, we make it more proactive, as if any user can declare Errata, but it needs to be moderated by data providers instead of having all the workload on the data providers. These are things that we are actually working on, but there are other things that we are thinking about in the distant future, such as having a notification service. So if you have downloaded a data and subsequently there is an Errata that has been created about the data, you will be notified and told you need to check your work because I think there's something problem with the data that you have used. But this is more of future things, maybe wishful thinking even, but we will see about that. If you want to contribute or use the Errata client, I have put the GitHub repository here. The documentation is also available for you to have the first steps and maybe even master the client. And if you have any questions whatsoever, I've put my email here and I will put it in the page for this workshop. I will be more than glad to help you out and get you started with Errata. We will be happy to have you. And that is it for me. Thank you.
Excellent, thank you so much. There's a couple of questions in the HackMD, but also, and then perhaps after the tooling and internals, we can have a bit of an open discussion here as well.
So no discussion now?
There's another presentation by myself,
There's
Mark
one more.
Greenslade. Yeah.
Right. So after Mark's, then I think we can
take questions for all of
talk openly in Zoom, but for now there's also some check the HackMD as well.
Yeah.
Okay, can you see my screen okay?
Yes, Mark.
Can you see my browser?
No.
So it's only showing the preview screen. Okay, that's fine. So yeah, my name is Mark Greenslade. I also work for at the IPSL in Paris. I've been working on ESDOC project for quite a long time. It's actually about 10 years old now. There's a kind of predecessor project called Metaphor, and then ESDOC grew out of that. Metaphor was put together for CMIP 5, and then ESDOC has kind of, as a brand, if you like, has coalesced around CMIP 6, but it does support other projects. So we're working with Cordex project at the moment. And its infrastructure is designed from a technical perspective to, upon open standards, but to support multiple projects. That's the idea. So I'm just going to talk about some aspects of the open standards, and in particular the ontology underlying the stock infrastructure, what we call specializations, which I'll come to a little bit later, and control vocabularies. So in relation to ontology, ESDOC has an ontology that's called the SIM, which stands for Common Information Model. It's now at version 2. It's a semantic model for documenting experiments, processes, outputs, simulations, you know, the full workflow that Sadie introduced right at the beginning of her talk. The current schema for this ontology is on the in the ESDOC GitHub space. So you can kind of view it there. It's like any ontology, it's kind of gets subdivided into so-called packages. Each package is around a certain theme. So a collection of data types around a theme. For example, data, DRS, which is data reference syntax, platform, which is the kind of supercomputing environments that the simulations typically run on. Science, designing, which is about the experimental protocols. So these packages encapsulate themes within the ontology. ESDOC tooling chain in support of ontology was started in about 2012-13. And I took a very kind of pragmatic view, because ontology engineering is something that you can quite easily go down a rabbit hole. And so what I did was created a system for defining or declaring data models just using simple Python, effectively Python dictionaries. So they're really the simplest kind of way of declaring these things. So here's an example for a numerical experiment. So it's just simply a data type, which has a set of properties, and we have a set of constraints over those properties. This particular data type inherits, what we call inherits, from another data type. So there's an association between data types. So, you know, this is quite accessible for simplified design of the ontology. We didn't rely upon third-party tooling because at the time when we started all this, the third-party tooling was pretty flaky. So we just went very low level. And it's actually kind of stood the test of time. So pretty glad we did that. This is a class definition, what we call a class definition in ontology. We also have enumerations, which are effectively controlled lists of terms. Those lists can be open or closed, whether or not they're extensible. And so we call these enumerations. So with this ontology mechanism, we can declare classes within the context of packages, and we can also declare enumerations. So these are just simple Pythonic, a simple Pythonic way of declaring all this stuff. But on top of those definitions, we build tooling, and the tooling is kind of three aspects. One is validation. So, you know, as the ontology is declared, it needs to be validated according to its own declarative rules. So we have a validation tool. Then it has to be parsed, because these are just, you know, kind of raw Python, doesn't really mean anything. So we parse them to higher level types so that they can then be become inputs to upstream tooling. And we also take the parsed types and hand them off to generators. And the generators are forward engineering code. So they're taking these declarations, which are validated and passed, and then from those we generate other code. So for example, this is a Python class that has been forward engineered from the declared ontology, which was, so we have a generator that will forward engineer this particular piece of code, but we could also forward engineer JavaScript code or let's say Rust code, different language bindings if we so wish to extend the ecosystem. So we take a kind of a meta approach to our ontology tooling. Here's the tooling output for the enumeration that I alluded to earlier. So yeah, that's where the schema lives. So we have, in this case, our ontology declaration. We have our tooling to validate, pass, and then generate upstream assets. And this all gets brought together in this library called ESDoc. So Python Earth System Documentation. And this is like at the heart of the ESDoc ecosystem. It's a Python library. It's mature, unit tested, pip installable. And with this library, you can create documentation, you can search for documentation, you can publish documentation, you can manage an archive of documentation, you can transform documents between different encodings. So you could have a document in JSON format, or maybe XML format, or maybe a custom format. And then it also encapsulates kind of IO, so read write to the file system, for example. So this is this tool, or this library, is really at the heart of the ecosystem, and then is used in several different scenarios. So here's an example for CMIP 6. So one of the ESDoc team is responsible for coordinating with all the different MIPs and stuff, and creating this mother of all spreadsheets, which is the CMIP 6 experiments spreadsheet, which is really a huge spreadsheet. And we use ESDoc to parse that spreadsheet and convert the data, the metadata information in that spreadsheet into archived or SIMV2 documents that are ready to be archived. So that's one usage of ESDoc. Another is transforming those archived documents into HTML for rendering, for viewing. Another example is if a third-party system creates one of these SIM documents, or one of the documents that you can create using this toolchain, they need validation reports. So we can validate these documents using ESDoc. And then lastly, we can also publish to the ESDoc documentation web service using ESDoc local SIM documents. So these are just like a few use cases of usage of ESDoc. So it's kind of like a low-level library that's used across the ecosystem. In terms of the web assets, so built around SIMV2, we have a set of web services, which api.esdoc.org. We have search, we have viewing of documents, and we have comparison of documents. So Sadie's talked about all those before. We also have the Errata service. And here's the set of endpoints that the API exposes. On the publishing context, create, delete, retrieve, update, and on the search side, searching by DRS or identifier or by name. So this is the web API, and the web API itself is built on top of ESDoc. So yeah, this is search and view. So on the left, we're searching for some documentation. On the right, we're just kind of viewing it. This is the Explorer. So on the left, as Sadie said, we've got a set of models organized by institute, and we have our realm process hierarchy. So that's the ontology and some of the tooling around it, but the ontology is kind of a schema, right? So it's static, it's constrained, it's defined. It doesn't really, the idea of a schema is that it's well defined and doesn't really, it does change, but it's not fluid, right? So, we have a problem, and the problem is when a scientist says, we want to capture some fairly random information about ocean advection schema or sea ice radiative properties or atmosphere transport layer, we're going into fine detail here, and the schema is not really designed for that. It's designed possibly to capture the details, but not what are those details. So we use what we call specializations for this. And so we say, okay, let the community own a set of specializations, let them define their specializations, and we give them a tooling to validate what they've declared, and then to generate upstream assets. The ESDoc role in this context, in the context of specialization, is simply to guide the experts in what they're doing and not to kind of be in the foreground. So if you go to the ESDoc GitHub space, you'll see a set of repos called CMIP6 specializations, and they're organized by realm, modeling realm. And again, the declaration of these specializations is using pretty simple kind of Pythonic dictionaries. And we give training, help, and support to the authors of these specializations, and then tooling on top. And the tooling is pretty much the same as per the ontology. It's kind of validation tools, parsing tools, and then generators to generate upstream assets, such as mind maps. So mind maps are a great way for community to visualize how they're organizing their specialization. We also do the specializations then feed into the comparator, because they effectively constrain what is being compared. If within the context of CMIP6, for example, we have pretty extensive specializations, and they will all be feeding into the comparator. So you will be able to, for models A, B, and C, look at differences in ocean advection as a result, assuming the modeling groups are fielding their documentation, of course. Another dimension to the ESDoc kind of tooling chain are vocabularies, control vocabularies. And we take a pragmatic approach to that as well. As Sadie said, we have this specialized library called PySSV. It's a vocabulary manager, Pythonic, it's mature, unit tested, etc. And that allows us to create vocabularies, load vocabularies into memory, parse them, archive them, encode them into, if you want JSON, XML, or whatever, and then read write to the file system. So it's kind of fairly similar to PyESDoc, but purely focusing on vocabularies rather than kind of ontology. And associated with PySSV is an archive of vocabularies, and most of those vocabularies in there have been sourced from the WCRP CMIP6 vocabularies, but we also support other communities, OBS for Mix, Codex, etc. This archive is ever kind of growing. Voila. So that's an overview of ESDoc kind of tooling chain for CMIP6. Let's just kind of go back to the beginning. Ontology, specializations, vocabularies. But what's important within the context of this kind of meeting or conference is that I think these do obey FAIR principles in many ways. This infrastructure is reusable across different projects. The ontology is extensible, the specializations are extensible, the vocabularies are extensible. The higher level tooling built on top of this will just consume whatever the inputs are. So if you self-organize around some kind of project that you want to use as a vehicle to explore this stuff, then you would start with creating your own specializations, perhaps your own vocabularies, perhaps extending the ontology, and then you would be able to use the high level tooling because it's built upon standards to then start bringing documentation into existence around that particular project and publishing that through the web platform that the ESDoc infrastructure provides. So, voila, that's my talk. Thank you. Should we proceed to questions?
That'd be great. If it's all right, because I jumped in first, in terms of on that very last point, which is really interesting and, as you say, really relevant for us here. What sort of support, how as a group or community do we go about this in terms of getting support from ESDoc Project Order?
Yeah, so the process there is you self-organize, so you create a small kind of working group, and then you reach out to ESDoc. You reach out to David Hassel. I'm not sure if David's on the call, or Sadie, her kind of project liaison officers, and then you will be allocated somebody to kind of accompany you, if you like, on your journey through the ESDoc landscape. We would set up a series of telcos to try and understand your requirements, to try and scope your requirements, because scoping is like important, right? Because a lot of these exercises can become can go down rabbit holes. So scoping is important. And then to give you training on tooling usage, or co-organized workshops, and then give you technical support when you get to the actual publication phase to make sure your documents are being validated and published correctly and appearing in the various web portals and stuff. And just kind of try and ease your journey through the ESDoc world. Yeah. So just reach out to us, self-organize, create a small working committee, and then reach out to us and start a dialogue.
Excellent. Okay, thank you.
If I may ask, I think it's very, very interesting, and I particularly love the Errata service and the information that you can get about the models from ESDoc in principle. Unfortunately, a lot of the models haven't filled in all the information yet. So, but of course, there's nothing you can do about that. But when it comes to the ontology, I'm a little bit surprised that you have not chosen to integrate any of the established technologies like RDF triples or something. It's a bit unfortunate that Oscar seems to have missed now the talk, but being from the ontology research group, he probably would be interested in this approach. Why specifically did you choose not to go with sort of more established technologies?
Yeah, when the ontology engineering effort on ESDoc started, there were no established ontology processes, tool chains. There were some standards around RDF&L and stuff. We're talking 2011, 12, 13, but the tooling chains were very flaky, and I didn't want to commit to those chains. So hence why I went very low level. But actually, the problem is not a question of whether we use open standards, because we do. It's really an encoding thing, because those Pythonic declarations that I referred to earlier, these can be, we use our generators, right? We have these generators that forward engineer assets. So for us, for this tooling chain, to forward engineer RDF, AL, etc., that then becomes part of a kind of triple store ecosystem. It's more of an encoding problem rather than a core problem. So we're kind of, let's say, took a pragmatic approach based upon where the ontology community, if you like, was at that time, and at that time, I would suggest it was quite fragmented. Also, for the specializations, I don't think they would even map to yeah, I mean, I guess you could tripleize them, but it's kind of a bit of a unique twist in themselves. It's the same with the vocabularies. Talking about the vocabularies, you know, we're in discussions with CEDA in the UK to publish our vocabularies upon their vocabulary server, which uses more open standards, if you like. But again, that's just an encoding thing. It's not actually a big deal for us.
Okay, I suppose for me, the intuition is always that this kind of format standards might also help with the fairness. But regardless, the other thing I was wondering is there seems to be a bit of overlap with the information that is dealt with in the CMIP6 data request. Now, I understand that you guys are also dealing with other communities somehow. But I know that Martin Hughes is working on a kind of more ontological and more, let's say, relational database friendly approach to the next generation of the data request. And I was just wondering if you have any contact there, or if there are any efforts ongoing to synchronize that up.
Yeah, so yeah, Martin, yeah, I've known Martin for quite a long time. And kind of followed his work on the DRS. In actual fact, the PySdoc library, I haven't detailed it here, but does have, you can pass the full DRS, or rather, you know, all his work can be imported and passed using PySdoc. So, you know, and in actual fact, we do use some of the content that is published through Martin's work within our ecosystem in support of CMIP6, because there's some metadata there that we require for, I think it's experiment documentation. So we do have a degree of collaboration, but yeah, it could be closer. Could be closer. You know,
Yeah,
I think ESDoc infrastructure could be used for the DRS, could also be used for ESGF. The metadata standards in ESGF are quite ad hoc in many ways.
Yeah, in fact, I was kind of thinking along the same lines. I mean, I don't know which technology in the end really should be used as the unifying platform, but there are these bits like all the metadata ending in ESGF and in ESDoc and in the data request that, by the way, more or less all of them could and should be extended to other projects beyond CMIP6, and partly they are. But to unify that all into kind of one ontology, that would be great.
Yeah, it's yeah, probably needs a funding vehicle to make that happen. And it's probably a 2-year effort.
At least.